Hello, my name is Vincent Schoondewoerd and I'm one of the imaging specialists at SVI and also responsible for the marketing. Today I'm going to talk about image quality control. As you may know, with the Huygens software we offer a complete image analysis workflow, from true deconvolution and restoration of pitfalls towards 2D, 3D visualization, object analysis, co-localization analysis, and object tracking. And for the analysis and visualization of your data, it is important to have high quality images. If images suffer, for example, from hot pixels, as you can see here in this scene on the left, you see these high intensity pixel values conserved in the Z dimension, and they are being rendered as pillars in this data set and considered as being objects. Of course, you can filter out these objects as shown here on the right, but preferably you want to start with good data. The same holds true for example, co-localization analysis, which is influenced by, for example, sampling. So if you correctly sample according to Nyquist, you can have a Pearson value that is 0.489 between the two channels, but if the same channels are acquired under different sampling conditions, 1.5 times under sample, 3 times or 6 times, you see that the Pearson value increases and you have just higher co-localization analysis. So there are quite a range of pitfalls that can be seen in your images. So undersampling, as I mentioned, your data your metadata may be incomplete. For example, if your pixel size is not properly defined, this can affect the analysis. Chromatic aberration, such as shift between channels, will affect your analysis. Clipping and saturation is not a good representation of your intensity distribution in your image. Hot and cold pixels, same thing. Bleaching. Crosstalk, where in this case microtubules that are depicted in brown are bleeding into the mitochondrial channel. Misaligned planes along the Z dimension, so slices may have been shifted, or you may have images that suffer from aberrant point spread functions like these banana-shaped ones. Luckily, we can now correct these and detect these automatically with the Huygens Image Quality Control options. It comes in 2 flavors. We have an add-on option for Essential and Professional, and we have a free online quality control tool. The add-on option for Essential and Professional can, of course, like all other options in Essential and Professional, be tested for free. Just visit svi.nl license request, fill out the form, and you will receive a trial license. You can, of course, also simply contact us at sales@svi.nl. So what are the differences then between the add-on option for Essential and Professional and the free online quality control tool? Both can accept all kinds of microscopy data. The sizes, however, are limited. Add-on option for Essential and Professional is limited to the amount of RAM in your computer, and the free online quality control tool, we've set a limit to 250 megabyte images, and that is because otherwise the server would be overloaded. What is detected automatically? The sampling rate and how this relates to the Nyquist rate, clipping, bleaching, crosstalk, chromatic aberration, the microscopy parameters, so the metadata quality, that is all checked in both. The add-on option in Essential and Professional only detects the level of SNR and whether this is reliably estimated, hot and cold pixels, stabilization, so drift issues, and the point spread function shape. and you can load bead images for that. The info that comes out, so the results are presented as in a report, and this report is in a comma-separated file with the numbers. Soon we hope to also offer you a PDF with the add-on option, and the free online quality control tool only generates a PDF. Both contain detailed information about every single problem in the image. The add-on option only has the visual interactive feedback and the online help, so links to the online wiki pages in addition to that. And most importantly, of course, the add-on option can directly link you to the correction options that are listed here in green. It also offers templates for correction, and these templates can also be used for batch processing. And soon we hope to provide you with complete workflow templates in which all the correction options have been bundled, so you can just batch process all and correct all the problems at once. So we support all types of microscopes and sample data with this QC tool, and you can load bead images. That can be one bead, or it may contain multiple beads. These can be used to track the monitor the microscope performance, or you can check what the quality of your point spread function is for deconvolution. The point spread function shape parameters that the add-on option spits out are the full width half max values in X, Y, and Z for the bead, for the stilled point spread function from the beads, and the theoretical point spread function that we calculate based on the metadata in Huygens. And you can compare all these numbers. We give you a level of symmetry of the point spread function, the sphericity of the surface. So in case you have a perfect sphere, which is never the case, you will have a value of 1, but the PSF is already a bit more elliptical, so it will have a value lower than 1, and if you have some irregularities in the surface, that will even be a lower number. Then we also monitor the point spread function for any tilting, and if there is a skew of intensities from the center offset. In terms of restoration options, so the quality control option in Huygens Essential and Professional can link you to the respective restoration options, which are the crosstalk corrector, the hot pixel remover, the bleaching corrector, chromatic aberration corrector, the optic stabilizer, and the PSF distiller. The blue ones that are marked blue are extra add-ons for Huygens, and the green ones are already present in the Essential and Professional Basic. How can Huygens be used with the image quality control option and the respective correction options? You may have a node log license linked to one computer, but can be remotely accessed. You can upgrade that to everywhere for one seat or one user at a time, and that one user at a time can use it then everywhere. So in all configurations you can use the quality control tool. If you add multiple seats, then multiple users can use it at the same time, also on any computer they like. And for example, you can have just one single seat or more seats for all microscopes in your facility and have Huygens running with the quality control tool on every computer there. A short disclaimer here. So the quality control outcome gives you a certain level of quality. And it is only meant, let's say, to be a guide and to help you with improving your images. The sensitivity of the warnings probably needs some further tweaking because there is a whole range of images and their quality. And it remains arbitrary, so where do we set the limits? That is still under development and will remain so. It's always good to have a closer look at your images with the Huygens restoration options and to visually inspect your image data with the twin slicer. So do a before and after check, so after correction. And of course we are interested in your feedback. And then let's move on to the demo. So I will show you both the free online tool and the add-on option. We are now at our homepage svi.nl. To use the online quality control tool, you need a username. For that, register on our website, fill in your credentials, go to your email inbox and validate your account. After that, go back to our homepage and look under the Tools menu. Here you find, besides the Nyquist calculator, the online image quality control option. Here on this page you can select an image that you want to get checked for issues and click on the Make Quality Control Report. You can upload files up to 250 megabyte uncompressed. There are also links to request a trial license for the add-on in Essential and Professional. So I invite you to just request a trial. This trial has, of course, all the functionalities because this quality control option has some limited functionality. Then we can download here the PDF with the detailed information. And if we look in detail in the PDF, we see an overall summary, as well as that the microscopy parameters are reasonable. The Nyquist is okay. There is clipping and the number of voxels clipped are listed here. Bleaching needs attention in the Z dimension. There seems to be no crosstalk and there is also no chromatic aberration in this image with respect to the shift. If you want to read more on these issues, on these topics, you can look at the pages below. We are now in Huygens Professional and I've opened a wide field image. And this wide field image I know has some hot pixels. And these can be seen if I slice through the image in Z. I see there pixels of high intensity that remain present when I slice through Z. But they're more apparent if I just move the cursor on the thumbnail and see the MIP rendering. So let's just now start the quality control option under the analysis menu. So here's a 2D histogram in which you always can find a lot of information about the image because it plots the intensities of channel 0 compared to channel 1. Here is another histogram mode in 1D. Here are the channels that I can toggle to, and here are the colors of the MIP, and if I'm colorblind or whatever I can change just the colors of that. I have here a list of issues that I can detect in the image, but I can also expand this list by going through the options menu, clicking on experimental options, and then I've expanded this list with, for example, hot pixels and chromatic aberration. So let's just now run the quality control tool, and Huygens now goes from left to right through all these issues and detects the problems automatically. So the ones in blue here are do not really need attention, but it would be good to just walk through them and read upon the details here in this list. So this meter already indicates whether this topic really needs attention. So the microscopy parameters are of reasonable quality. The Nyquist rate is fine. The SNR estimation is also reasonably good, but the clipping really needs attention. So this is the same image that I used in the online quality control tool, and here it also shows you the clip count. So the amount of voxels that are showing clipping. And if I want to see more detail, I can go to the image histogram and look at the different channels and see that there's a spike at 255, which is the maximum count of an 8-bit file, indicating that there is clipping. Then I also can go to the tab Hot Pixels, and it may be that the clipping is caused by these hot pixels, which are high intensity values. That may be the case. So this also needs attention. I can click on the Investigate button, and it gives me a hint on what I can do. Check the MIP rendering for vertical lines and or the 2D histogram for diagonal lines. Well, that's the case. So that could be a sign of hot pixels. And same here with the vertical lines we see present in the image. We can go to the online help and a lot more documentation. And here on the left there's also a lot more information on what hot pixels really are with cartoons. So if we want to get this fixed, we go to the hot pixel corrector or the hot pixel remover, and we see on the left side the hot pixels, and on the right side a preview of the image with the hot pixels corrected. So this is automatically detected for both the channel 0 and channel 1. And if we now click here on the button correct, we get a corrected image, and this corrected image is automatically loaded in the quality control tool. And you see now in the MIP that the vertical lines are corrected for. To get to the other issue of bleaching that was detected, we need to run the quality control tool again and even see if there are new problems detected because of the hot pixel correction. Well, there seems to be bleaching, but now also chromatic aberration puts up a flag. Let's first check the bleaching. Check the bleaching corrector, and we see in the bleaching corrector, after estimation, that the green channel, that is channel 1, has a severe drop of signal of the mean intensity over the Z stack. And we can correct for this. Okay, and now an image has been created with the bleaching corrected, and you see that the tails here are of less intensity than before. Okay, and we can run the quality control tool again, but I know that the chromatic aberration was really affected by the bleaching, so that was the issue. Okay, so we have now an image that has been corrected for hot pixels and for bleaching. Let's just now check another image, and for that I want to open a bead image. And this bead image I cropped to 2 channels. Normally it would be 4, but that would take a bit too much time for the demo. So again, this bead image also needs the experimental options. I check here that this is bead data, so I'll put some a priori knowledge in, and also the size of the bead, which is 170 nanometers. And if we now run the quality control, then we see in a few minutes, this takes some time because the PSF shape is now determined, and that involves quite a lot of parameters. And you see already, if you look in the MIP, that the yellow channel looks quite nice and vertical, but the blue channel is kind of somewhat tilted. And it also seems that they are both misaligned. And that is also what the quality control tool detects. There is chromatic aberration. We look in the details. We see that the shift is quite severe with microns, a micron shift in X, Y, and Z for the channel 1 as compared to channel 0. Channel 0 is the reference channel. So we can correct for this. Let's estimate the shift and correct for it. Okay. Yeah. So now we see that it is somewhat shifted. We need to rerun the quality control for the PSF shape. Again, that is a kind of a disadvantage that we need to do that again. But as you've seen with the previous image, they can affect each other. So it's important to fix the problem and get the image rechecked again. And again, you can read upon the problems in this menu in a second. Okay, this takes a bit more. Yeah, here we are, PSF shape. So Huygens detected from the microscopy parameters that there is a refractive index mismatch, and so a theoretical PSF might be preferred for deconvolution instead of this experimental point spread function. That would be a choice up to you. The size of the full width half max of the PSF is different from the expected size, and if we look at the details, we see that channel 0 is not so bad, so the bead PSF and theoretical point spread function match quite nicely, but we see that channel 1, that is the blue channel, has a theoretical value that is quite lower than the other channel values, or the bead and the PSF. And also there seems to be some asymmetry. And if we export this, all these to a report as a comma separated file, and we open that in an Excel sheet, then we see all the parameters that the quality control tool spits out for this specific bead. And let's focus now on the yellow highlighted versions, which is the principal axis component indicating the severity of tilting of the bead, and we see that the blue channel is a lot more tilted than the channel 0. And we can just simply look at the MIP and see that this is actually true. Just as a reminder, a free trial can be easily obtained via our website svi.nl license request, or contact us at sales@svi.nl. Thank you very much.